This was the scene in Minot, North Dakota, in early spring 1969. The Souris River had flooded before, but this was the greatest flood in over 65 years. By the time the Corps of Engineers was called in to help, there was little that could be done. 6.5 feet over flood stage at its crest, the flood accounted for $30 million in damages. And the waters did not recede below flood stage for 40 days. The city and its people would soon spring back and rebuild. But what they did not know was that in only a few short years, they would be hit by a flood of much greater magnitude than the one that had just left them staggering. The flood of 1976 was to rise a foot above the 1969 crest. Spring flooding was anticipated in the Souris River Basin in early January due to abnormally heavy rain and snowfall. Much of this precipitation fell during the late summer and fall of 1975, which resulted in the ground being saturated at freeze-up and a larger than normal amount of runoff in the spring. By March, water equivalent on the ground, in the form of snow, averaged 4 inches. The high amount of moisture had set the stage for a spring flood if the melt came quickly. And quickly it came. Temperatures in the basin rose into the 50s and lower 60s. But no one was to be taken by surprise this time. Plans were made early, and many necessary supplies were pre-positioned in key areas. On March 25th, the National Weather Service predicted that the stage at the Broadway Bridge in Minot would reach an elevation of 1,554 feet above sea level, or 5 feet above flood stage. The Corps of Engineers were quickly called in for assistance in the flood fight. An emergency operations center was set up for coordination of activities and dissemination of information to the public by way of the news media. Meetings were held with community officials and contractors to discuss flood potential and emergency construction plans. Specifications for emergency levees were completed. Satisfactory borough materials were located, and contractors began building the 35 miles of levees that were needed to keep the river in its channel. Ideally, levees were constructed out of clay or clay-like materials because of their resistance to erosion. Once sufficient quantities of these materials were located in readily accessible areas, borrow pit operations were established. A ripper tore material loose for 2 front loaders feeding lines of waiting trucks. Following established routes with flagmen and warning signs at major crossings, the trucks carried their loads to a bulldozer waiting to push it into place and compact it. By this time, a surveyor had already laid out the route that the levee would take. Snow and surface vegetation, as well as trees and stumps, were removed. Even railroads running in the levee path were removed to ensure a firm, impervious foundation for the levee. Trees on the riverside of the levee were left in place to help prevent erosion from strong currents and floating ice and debris. The levees were, wherever possible, constructed with a slope of 1 on 2.5 and a top width of 10 feet. This 10 feet allowed trucks to continue working raising the levee as forecasts were changed. Levees were also kept back from the riverbank as far as possible to prevent collapse or foundation failure. Close eye was kept on the rising water levels. River gauges, such as this wire gauge, were checked regularly. By lowering a weighted wire to the surface of the river, accurate readings were made and reported to the Emergency Operations Center, where they were posted. Where earthen levees were impossible to build, or where they needed to be slightly raised, sandbag levees were constructed. This required the help of hundreds of volunteers. Each sandbag was filled only half full, and the open end left untied. The opening of the bag was laid downstream, overlapping the bag laid before it. Each successive layer was alternated, building to a slope of 1 foot vertical to 3 foot horizontal for a strong, stout levee up to 3 feet in height. Many sandbags were stockpiled near key areas in case of immediate need. Sandbag ring dikes were also used around manholes to control the problem of leakage. These ring dikes were raised above the level of the river surface. If available, metal conduit or concrete pipe was used with the sandbags to cut down on leakage and add stability to the chimney. Sandbags were never placed directly over the manholes because of the immense water pressure that built up. Where it was possible, this problem was alleviated by plugging outlets into the river beforehand to prevent water coming back up into the system. The National Weather Service again raised its forecast for the flood crest. The Lake Darling Dam, 25 miles upstream from Minot, was able to delay the crest, allowing more time to raise the levees. But as the spring runoff poured into Lake Darling, the reservoir reached its capacity, and measures had to be taken to prevent failure of the dam. Downstream in Minot, workers hurriedly raised the levees to handle the increased flow. Trucks brought in more loads of dirt, and bulldozers worked the material into layers of only 9 to 12 inches to facilitate maximum compaction. Unfortunately, the high flows brought with them increased water velocity. The resulting scouring action caused chunks of the levee to break off and fall into the river. Efforts were quickly made to restore the integrity of the levees, and where erosion was a major problem, steps were taken to slow the process. Dike patrols were established to keep a close watch on the condition of the levees 24 hours a day. Any weaknesses or erosion problems were promptly reported to the Emergency Operations Center, and repairs were made. A total of 100 rolls of snow fence were placed on the levees at water level to break up the river current and wave action on the levee surface and thereby reduce erosion. But the major erosion fighter was polyethylene sheeting, 52 rolls of it. Where it was possible, the sheeting was laid down on the levee before the waters reached flood stage. Starting on the downstream end of the surface to be protected, poly was rolled out and anchored at the base by digging a small trench, placing the poly in the trench and backfilling over the poly. In other locations, poly was only anchored with sandbags at the base and the top. Each sheet overlapped the previous one by 2 to 5 feet and anchored with sandbags for maximum surface protection. Where erosion became a problem after the floodwaters rose, poly sheeting had to be laid in the wet. Each sheet was weighted with small sandbags or small quantities of sand or rock tied to the bottom edge of the sheet. This edge of the sheet was cast out into the water and allowed to settle down onto the surface of the levee. Counterweights consisting of 2 or more sandbags connected by a length of 1/4-inch rope were used to anchor the center portion of the poly. As the flood crest forecasts were raised, so too were the levees, until they towered from 8 to 18 feet in height. In fear of possible dike failure, residents in the floodplain were evacuated. 12,000 residents, approximately 1/3 of the town's population, were moved to emergency housing, leaving their homes and possessions in hopes that they would still be there when they returned. At the levees, water seeped through the soil and ponding became a problem. Pumps were moved into position to keep up with the seepage. Some ponding was allowed to counterbalance the hydrostatic pressures in the levee area. But when ponding exceeded acceptable levels, and when 2 1/4 inches of rain suddenly fell across the river basin, pumping was accelerated to remove the excess. The Souris continued to gain strength as the waters rose. In some areas of the levee, the waters crept up only 4 inches short of the top. But finally, the river ceased its climb. Early on Easter morning, the 18th of April, the Souris River crested at 7.1 feet above flood stage. The levees held, and there was no water flowing destructively through the streets of Minot. The disaster of 1969 was not to repeat itself this year. $6 million had been spent in the fight, but almost $60 million in damages had been prevented. The people of Minot met in worship that morning and rejoiced that their homes and possessions, their very lives, had been saved. The flood of 1969 had left the city heavily damaged and its people distraught. But the flood of 1976 receded 38 days after its start, leaving dry city streets and people reveling in their victory. They had won. With the help of the Corps of Engineers, the National Weather Service, other federal and state agencies, and hundreds of volunteers, they had conquered the river. Residents could now return to their homes, knowing that the destructive force that had threatened them now flowed peacefully downstream.